Sure. This is recording all the good things. All right, I made an epic mistake last period, which is why we're filming again. So this unit, Unit 5, is called the definite integral. And this unit is officially the start of the second half of the AP Calculus course. The first half of the course focused on limits and focused on the derivative. There once was a time where you guys did not know what a limit was. There once was a time where you had no idea what a derivative was. Some of you might still be thinking, I think I'm still at that time in my life that I don't really know what a limit was or what a derivative is. No. We all know that when I say derivative, derivative means, what does a derivative mean? What is it that you're finding? One more time, Jackie? Slope of tangent line. Derivative means at the very, very base level that you're finding the slope of the tangent line to a curve at a given point. Now, we've gone through, we've evolved, we've got all these derivative rules. You guys all know that the derivative of the sine of x is, play along with me here, derivative sine of x, everybody knows is the cosine of x. Everybody knows that the derivative of natural log of x is 1 over x. Everybody knows that the derivative of e to the x is e to the x. Everybody knows the quotient rule. Low d high minus high d low all over low low. Everybody knows that the derivative of tangent of x is secant squared. Everybody knows that the derivative of arctangent of x is arcsine. No, not arcsine. Stop embarrassing yourself.
Is it a 1 minus something?
No.
Oh, no, it's 1 over
1 minus 1 plus x squared. Or 1 over x squared plus 1. But the idea is the derivative is slope of the tangent line. We've done application problems with the derivative. We've looked at physics. We've looked at rates of change. We've looked at the mean value. We've done all these things. Everybody's still with me, right? That was the derivative. Tomorrow's test is on applications of the derivative. And there are 6 big things being tested tomorrow. And what are these 6? Mean value theorem. What else? The extreme value theorem is being tested tomorrow. L'Hopital's rule is being tested tomorrow. Optimization, all those application problems. You want to make things really big or really small. What else? Kevin? Implicit differentiation. Last thing? Related rates. How things are changing over time. The multiple choice section is going to test all 6 of those things. The free response will focus on my 2 favorites. The last 2 things that we've studied. Related rates and implicit differentiation. If you know those 2 really, really well, free response is going to be a good experience for you. Multiple choice is going to be tough because it mixes all 6 of those things together. But we're going to be okay. But today is not about that. Today we are moving into a whole new direction. I'm excited about this unit. It's going to go well. I'm also excited because grades always go up in this unit. Scores go so high. Anybody want their grade to go up?
Me.
Yes, okay, these are all the people that are going to do their homework. Eric isn't interested in his grade going up. Eric, that's not possible. Or you're so tired because it's Monday that you don't even have the will to raise your hand. He's using his hand to hold his head up. Okay, so in this unit, the topic is called the definite integral. We've never talked about the definite integral. Today is going to be a very notation, easy, ground level. So I'm on page 7. Here's the new notation. This fancy S with the little a and the little b and the f of x and the dx. First of all, you need to know how we read this. This is going to be read as the definite integral. The definite integral of f of x with respect to x from x equals a to x equals b. That's just how you're going to read this notation so that you sound smart and educated and you impress the ladies or the gentlemen, whoever you are trying to impress. But everyone is going to read this notation as the definite integral of f of x with respect to x from x equals a to x equals b. One more time. Everyone's going to read this notation. 1, 2, 3.
The definite integral of f of x with respect to x from x equals c to x equals b.
First of all, that's an A. I'm not sure where the C came from. Okay, one more time. How do we read this notation?
The integral of f of x with respect to x from x equals a to x equals b.
Okay, great. Now you sound educated, but you know nothing. You know not names like I can read it, but I don't know what this means. Just like derivative was confusing at some point, but we know that derivative means find the slope of the tangent line. Okay, here's what it means. What the question is going to be, how much area? I'm asking you an area question. How much area is bounded by 4 things? 1 is the graph of f of x. Number 2, the x-axis. Number 3 is the line x equals a. And number 4 is the line x equals b. So when I ask you a definite integral, or when you see the notation, the question being asked is, how much area is bounded by 4 things? The function that we're talking about, the x-axis, the vertical line x equals a, and the vertical line x equals b. It's a geometry question. I'm just asking for an area computation. All the friends are okay?
Yes.
All right, so if I look at this diagram over here, let me just lower that a little bit. So this is the graph of f of x. Okay, feel free to get the markers out if you want to do a little bit of coloring. The definite integral of f of x is asking area question. Area bounded by what are the 4 things again? The graph. The x-axis, so draw on your x-axis.
The line of x equals a.
That's x equals a, so it's a vertical line.
The line of x equals b.
The vertical line x equals b. So shade in that region, please. What region are we actually talking about here? The area bounded by the function, the x-axis, the vertical line x equals a, and the vertical line x equals b. Make sure you know what region we're talking about. Shade in the region, Carlos. Okay. The region that I'm looking for is that guy over there. And everybody's okay with that? We're good? Okay. So here's the thing. Some of you are going to start saying, because some calculus teachers out there say this, and God, I hope you don't have a calculus professor that says this. Some people say that the definite integral measures the area under the curve. And that's all they say. They say the area under the curve. What's wrong with that?
It's not bounded.
What makes sense? What's wrong with that?
If the curve goes the negative side, you the area under the.
If what you say is the area under the curve, what you're implying is, here's the curve, where's the area that I'm interested in? All of it. How much area is there?
Infinite.
There's an infinite amount of area. We're not interested in that. We are specifically interested in bounded, trapped, confined area. All the friends are okay?
Mm-hmm.
Think about your life as a calculus student. You feel trapped, confined, bounded, all the things. And nobody cares about it. Everybody good?
Yeah.
All right, a little bit of vocabulary coming here. F of x, so I'm down here. I'm going to scoot this up a little bit so I can write at a better level. Okay, when you see this notation, this is just the anatomy lesson here. F of x, we're going to call this the integrand. I-N-T-E-G-R-A-N-D. The dx is your variable of integration. I'll get out of your way in just a little bit. Variable of integration. The sexy S looking thing here is the integral sign. The A is called your lower limit of integration, or the lower bound. The B is your upper limit of integration. And I've got a poster somewhere that'll come out. When you put all of those things together, that's what we're going to refer to as a definite integral. And a definite integral just means area. So one more time. F of x is the integrand. It's the function. The dx is your variable of integration. Right now, while we're in the baby end of the swimming pool, it's going to be dx all the time. As we go further, we're going to look at dy, dt, d theta. It's going to change all the time. The integral sign, lower limit of integration, where do you start measuring area? The upper limit, where do you stop measuring the area? Everybody okay with the basics? Mm-hmm. Okay, good. All right, so let's actually get to this. And all I need you to do today, trust your instincts. You're going to be just fine. So at the top of page 8, we're looking at the very first definite integral problem that we're going to look at. 1, can I get you to read using your new vocabulary skills? Read part A. Not Juan, sorry. Playing the role of Juan today. Jose.
F of x equals
Part A, how would you read this to impress the ladies in your life? Yeah, go back to your notes if you need to.
The definite, no, the notation.
Yeah, how would you read it?
The notation. Wait, no, the definite of integral of f of x with respect to x from x equals 0 to x equals 3.
Well done. That's how you would read it. Jackie, one more time. How are you going to read it? That's okay. You just read it. You heard it.
Okay. The definite integral of f of x with respect to x. Wait, from x. To x from x equals 0 to x equals 3.
Excellent. Pedro, how are you going to read this?
Definite integral with respect to x from x equals 0 to x equals 3.
Okay, last one. Caleb, how are you going to read this?
The definite integral of f of x with respect to x from x equals 0 to x equals 3.
Love it. The definite integral of f of x with respect to x from x equals 0 to x equals 3. Great. What does it mean? What am I looking for?
The area.
I'm looking for area, bounded area, 4 bounds. I need to hear all 4 bounds. The x-axis, the graph, not x equals a, not in this
X
case.
equals 0.
X equals 0, the vertical line x equals 0, and?
X equals 3.
And the vertical line x equals 3. Eric, so this, I'm asking for an area computation here, right? Area, how much area is bounded by? What are the 4 things again? Go back to your notes if you need to.
X-axis.
Hold on, you're not Eric. Eric. The graph of f of x. The x-axis. The line x equals what? The line what? X equals 0?
The line x equals 3.
Okay, good. Everybody knows how to read it. Everyone knows what I'm asking for. Good, go give me the answer.
Huh?
Go!
Oh,
Fly, monkeys, fly!
What?
Come on. All I'm asking you to do is find the area. How?
Yeah.
Trust your smarticle particles. I have faith in your smarticle particles. That is the graph.
Oh.
A very carefully, beautifully constructed graph.
Ah.
It's a piecewise function, right? I want to know the area bounded by the graph and the x-axis from x equals 0 to x equals 3.
Isn't it A, mister?
Isn't it A?
Yeah.
Whatever these limits are, that's what we're going for, from x equals 0 to x equals 3. Now, God, you all have learned so many things, so much geometry. Let's not regress to where you were back in those days. I would expect that you guys know how to find the areas of what kinds of shapes? Triangles are friendly. Rectangles. Even bigger triangles. Triangles, rectangles, other things. A rhombus. Now we're showing off. Squares. Circles.
It's the A's.
I hear trapezoids.
It's the A's.
This is none of those.
You go and break it up.
Kevin, what are you going to do?
You gonna break it up.
You're going to break it up, yo. That's what I heard. What do you mean by that, Kevin? What are you going to do?
I see 3 different shapes of that.
You see 3 shapes.
Alright.
You know, you see where like the slope starts getting more.
Like here?
Yeah, right here.
Yep.
You could like put a line so you can touch the other side.
Is everybody okay? Is everybody seeing something like that?
Yeah.
Is that legal?
Yes.
Did I have to tell you that that's legal?
No.
You know how area works. You've got 1, 2, 3 shapes. So here's how I'm going to write this. The definite integral is going to be equal to the area for the first shape plus the area for the second shape plus the area for the third shape. Area for the first shape, Delia, how would you find the area of that shape?
You do 1/2
Yep.
times 4 times 2.
1/2 times 4 times 2. I agree. Why is that?
Because the equation for finding the area of a triangle is
Area of a triangle.
1/2
1/2.
times lane. No, 8.
Okay, normally we say 1/2 base times height. And for a triangle, whenever you draw a triangle, however it looks, if this is the base, the important thing about the base and the height, there's a really important thing about base and height that we're going to get right here. It's not half. There's a relationship between the base and the height. They have to be perpendicular. So even if you have to go outside of the triangle, that guy over there is the height because the base and the height are perpendicular to each other. Okay? Then we've got a rectangle. Area of a rectangle.
4. Oh.
We're going to do, what is that, 1 times 4. Okay, 1 times 4 because we know that the area for a rectangle, call it base times height or call it length times width, easy enough.
Yeah.
Okay, how about this last one?
What is it? 1/2.
1/2.
1
Times 1
Times
4.
times 4 because it's triangle, 1/2 base times height. Easy stuff. We got this under control. Okay, what's that area?
10.
Yes.
This should be 10. Now last class they get themselves all tripped up like, what are the units? We need to have units. We're sure we're supposed to have
10
units.
units.
I wouldn't say 10 units because this is an area calculation. If you really want to get specific about this, you would just say 10 units squared and it would be okay. Everybody good?
Yeah.
Okay. Triangle, rectangle, triangle. My question for you all is, do you have to break it up, triangle, rectangle, triangle, or do you have other options?
What's the easier way?
That is an easy way and that works and they're 100% okay. Does anybody see another way to split this up?
Which one?
Area of half a trapezoid.
Trapezoids? Where do you see trapezoids?
Half of one.
What do we remember about trapezoids?
Isn't it 1/2 the other?
Trapezoids have a special property. There's something that has to be true. There's 2 bases and something special about the bases. Bases have to be parallel.
Oh, so just the line.
So let me draw, and I will get this one in your notes. So area for a trapezoid, you guys may remember, is 1/2 base 1 plus base 2 times the height. With the trapezoid, you have to have a pair of parallel sides. In fact, you want only one pair of parallel sides. The bases are the sides that are parallel. The height is perpendicular to the bases. Everybody okay? Okay, it is also possible that you draw your trapezoid that way. And where are the bases now?
On the sides.
The bases have to be parallel, so where are they? Which way are they? Can you guys show me with your
Left,
arms?
right.
Should be this way, right? So base 1, base 2, where's the height?
Perpendicular to the.
Perpendicular, so now we're going across that way?
Yeah.
Okay, so if you remember it this way, so let's do the area a different way. I want to cut this here
Yes.
and just do 2 shapes. The bottom shape is a trapezoid. So trapezoid, 1/2. How long's the first base?
3.
3?
Yeah.
Where do you see the first base?
Bottom.
There's the first base. Second base
1.
has a length of 1. So 1/2 of 3 plus 1, what's the height?
4.
Because the height has to be perpendicular to both. 4 plus the top piece, should not be a surprise, is 1/2 times 1 times 4. 3 plus 1 is 4. Times 4 is 16. Take half of that. 8. 8 plus 2, we're going to get 10. Hopefully not a surprise, the exact same area from before. Everybody good? All right, so what you can do with the next couple. I'm just gonna walk around. Pick up the homework corrections. What's up with that?
I have a question on this one. Since
I'm gonna let you dangle on that for a little bit because C's not 100% right.
Picking up the homework corrections.
I know, you didn't think I was gonna say that.
Teaching the solutions. Maybe it's not real.
7, 8. Oh, from 1.
You're just gonna,
Oh wait, never mind. We already have this. We already have this.
So, 10
Nice.
26.
Nice. Keep going. And the right answer, 1.
when you just do the area of this right here?
Looking good.
I don't know if that's the question.
0. Well, it's from 3 to 0.
8? Is that 8?
I think it's the same because it's everything.
It's from here to all this. Like here, when you're pero como dice aquí, so ya sabíamos que este era 10 y este es 16 y este es 8, so toman los dos 24, pero luego quitas este pedazo.
All right, Carlos, I'm coming to you on this one. Heartbeat, can you read that notation for me?
The
Definite.
definite interval of f of x with respect to x from x equals 3 to x equals 5.
Everybody okay? That's how we're gonna read it. I need to make sure that you are gonna sound smart and educated. Bento, what am I actually asking you for here?
The area
Area from where?
from x equals 3
From x, the vertical line x equals 3
and to x equals 5.
to x equals 5. Tell me more. Because it's area, there's 4 bounds.
Oh,
There's the graph, and then the last one?
and the x.
And the x-axis. And was this one like redonkulously easy?
Yes.
What do we get?
16.
16, right?
C.
Base times 2, 16. If you really want to show off 16 units squared. Get this under control. Jose, can you read part C?
The definite integral of f of x with respect to x equals 1 to
Excellent. The definite integral of f of x with respect to x from x equals 1 to x equals 7. Walking around, I saw just about everybody had that. That's the region. What shape is that?
I don't know.
Yeah. It's the technical name. How many sides?
You can use 2 trapezoids.
How many
and 1
sides?
side.
6.
1, 2, 3, 4, 5, 6. Name for that?
Hexagon.
Hexagon. Now, you don't have area formulas for hexagons, but you do have other area formulas that you can use.
Yeah.
Okay, how are we going to cut this up?
We can do a big rectangle
Where?
from x equals 3 to x equals 5.
Okay, from x equals 3 to x equals 5.
Yeah.
Okay. So this is one they'll be able to find?
Yeah.
How about this guy over here?
Yeah.
Yeah.
Triangle, yeah, Delia?
Can we just add the ones from 1 and 2 and then just find the area of the last triangle?
Hold that thought. Hold that thought. Everybody's good with those two. Like, we know how to find those. But now you're still stuck here.
Yeah.
How are we going to find the
You
area
can
here?
do a small triangle. Like do it horizontal on the floor.
Depending on how you want to do it, you might think like cut it here. Is that the small triangle you're talking about? Okay. And then
And do that.
you could cut like going across there.
Or you
And
can
so
do
you've
it
got
like that.
rectangle
And then a triangle.
and a trapezoid.
That's what I
So
was thinking.
we've got
Just
options.
strike that 'cause we
Lots
don't
and
really
lots
do
and lots of options. Go find that area for me. How you choose to do it is irrelevant. We should all get the same area.
I did something else yesterday.
Show me what you got.
Well, at first, you know that we did the first one,
Yeah.
and then I did the other one.
Yeah.
So I just add them and I found the last one.
Yeah.
But then I subtract the little piece from 0 to 1.
You are the second person today, also the second person ever, who's recommended going that way. Way to go. All right, so this first one is that 2 times 2. 1/2. 2 plus 1 with a height of 2. 1/2 of 1 times 4. Plus 2 times 8. Plus the last one, 1/2 times 8 times 2. And if all goes well, 33. You're here. You're alive. Kick him out of his seat. Good. Thank you. Are all the friends okay? All right, let's look at part D. Okay, for the sake of Ashley, who just walked in, Evelyn, can you read part D?
The definite integral of f of x with respect to x from x equals 3 to x equals 0.
Okay, the definite integral of f of x with respect to x from x equals 3 to x equals 0. Roberto, what is it that I'm actually asking you to find? Be specific.
Under the graph of the curve,
The area under the graph of the curve
yeah, from x equals 3 to
From
x equals 0.
x equals 3 to x equals 0.
Above the line.
And there's one more bound that you missed.
X-axis.
And the x-axis.
Mr. George, can I
Yeah.
have another copy?
Yep, I'll get that in just a second. Anybody notice anything different?
Yeah, it's backwards from the first one.
It's backwards from the first one. In the first one, I'm asking you to find the area underneath the curve from f of x, I'm sorry, underneath the curve f of x and the x-axis from x equals 0 to x equals 3. And in that case, we came up with 10. This guy, I'm saying, find the area bounded by f of x and the x-axis from x equals 3 to x equals 0. What's different is the direction. Rather than going left to right, you're going right to left. What's going to happen is that you're going to get the opposite of the integral from 0 to 3 of f of x dx. If you switch the direction, you switch the sign. So what's the area going to be?
Negative 10?
Negative 10. You're going to get negative area if you go from right to left, and also if you have area that's below the x-axis. Okay, with that said, see what you can do with the challenge problem while I get Ashley set up here. Ashley, do you have corrections for me? You have corrections for me, right?
Yes, sir.
We did these in class the other day.
I think so. I'll check.
I hope you do. Yeah.
Most of it? So this also in respects to the graph?
Everything goes back to the same graph. Find the value of k so that the integral, I know it's hard, I can't get it up on the board here, 0 to k of f of x dx is equal to 22. Trust your instincts here. I have faith in your smarticle particles. All I'm doing is pushing your thinking a little bit more.
To here it's 10, and to here it's 16, and to here it's 33. So
Trust your smarticle particles.
What
wouldn't
is?
it have to be in between?
Maestro.
These are the equations.
Because like, it would have to be because it has to
Is the answer 4.5?
Yep.
Oh, well, for just a
I got the same answer too, so.
You get the same answer. I sit next to a cheetah.
No, I actually did. That would actually drew one right here.
Nice. Okay, keep going. See what you can do with the next set of problems. I mean, if my challenge wasn't challenging enough, let's see what you can do now.
Mister, you should have teach us.
I said what?
Why can't we just do this the whole?
Yeah.
Yeah.
Oh, good. Let's just teach one thing 180 days in a row and hope it's the one thing that's on the AP exam. I would rather die. I know some of you would rather kill me, so it's a good combination.
It is a 10, and then base square is going to be 8. So 10 plus 8 is going to be
So unlike before, and I think most of you guys have already snapped to this, we already know that the area from 0 to 3 comes out to be 10. Right, and the question I'm asking is, how far do you go? How far out do you extend the line so that you get to exactly 22? And I heard some folks say, well, this part's 10, and we found the area from 3 to 5, and we found that that area is 16. So if I was looking at a multiple choice test, what I know about K right now, K has to be between what numbers?
3 and 7.
Between 3 and 7, sure. I think we can whittle it down even smaller.
3 and 5.
Is everybody okay that K has to be bigger than 3?
Yeah.
If K is only 3, I get 10. Could it be 5?
No.
It's going to be way too much area, so K is somewhere between 3 and 5. What did you guys do to get the exact value?
Well, at first we know from 0 to 3 is 10, right?
From 0 to 3 is 10.
Then I cut the other half, like from 3 to 4.
Yep.
I know that half is 8.
Okay, because we're dealing with a rectangle, so that's 8.
And then we know that the both sides are half, so I cut like half from
So
4.
you cut this guy in half. You get some really good geometry thoughts going on here.
Then I got 4.
And then you got 4. Not the only way that you can do it, but is everybody doing okay?
Yep.
Alright, so K is going to be 4.5. You guys are doing very well with this. So it's time for a push. It's time for me to take some things away from you. Not your will to live.
The graph.
I want to take away the graph. I want to take away the graph. Hey Zeus, can you read for me this first one using that best notation? Best notation you got. How would you read it?
Yeah.
Definite integral of what? Definite integral of 3x plus 2
With respect to x
with respect to x
equals 1
from x equals 1 to x equals 4. And Evelyn, what is it that we're actually trying to find here? The area, but area, I need 4 bounds. What are those 4 bounds?
3x plus 2.
The graph of 3x plus 2, the x-axis,
X equals 1.
x equals 1,
X equals 4.
x, perfect, go for it. See what you can do, we'll talk in a little bit. Trust your smarticle particles and your neighbor's smarticle particles. More people seem to have a good idea. Ooh, 5 people. Yes, sir. Okay, now you want to be careful. This graph is not 3x plus
No,
2.
but I'm trying to see like from the function from here. I'm trying to see from the area. Because right here it says 2x is from 0 to 2.
I agree with you.
So whenever
So that's that
I plug it in 2, I see that it's 4.
Yep.
It's 4.
Oh, I see. You're going deep.
Yeah.
You're going deep.
So
That
what
I'm going to let you go deep. Okay. Just want to take a beat on where we are. Everybody was doing really well just a little bit ago. Why?
Graph.
You had the graph. I have taken that away from you. But what is the function here? 3x plus 2. Anybody know what the graph of 3x plus 2 looks like?
A straight line.
It's a straight line. Passes through the point 1, 2. You have a slope of 3. Specifically, this definite integral is saying, here's the line y equals 3x plus 2. Here's x equals 1. Here's x equals 4. Go find the area. This is a trapezoid. Okay, if I'm going to find the area of this trapezoid, you guys know that it's 1/2 base 1 plus base 2 times the height. The bases are parallel. The height is perpendicular. So how long are the bases?
1.
Not 1 and 4. The bases, how do you determine the height of the base? You go up to that point on the curve. What are the coordinates there?
1, 5.
1, 5. I know that because this point's on the line. This guy over here? 4, 14. So my first base is how long?
5.
5. The second base? 14. And the height, and I know it's confusing to say
3.
height. When you look at this, the height is perpendicular to the bases. So this is 3. 5 plus 14 is 19. 19 times 3 is 57. If all goes well, you get 57 over 2. Did any of the friends get 57 over 2? Okay, good. Keep going. Don't let me slow you down here. Keep going. I'm just being tricky. Don't let Abraham get lost. We need him. Otherwise, who else is going to interrupt my 20 minutes every night?
No. After that, negative of 0.
Ah, thanks.
It is 3 times 1. It's 3.
Eric's got some good ideas.
Just removing the negative sign.
1 is x.
Mr.
Yeah.
You have this one? Because it's actually
Yeah.
So if you're going to get to include this,
The x-axis is always moving backwards.
Do it.
No, yeah, wouldn't show.
If you guys remember, what does the graph of absolute value of x look like? It's the V shape, right? So there's your V. There's the graph of absolute value of x from -2 to x equals 2. This is the area that I'm after. How much area? I've got a trapezoid. So this should be 1/2. The base is 2, the height is 2. Plus 1/2, the base is 2, the height is 2. You get 2 plus 2, area should be 4. Okay? I don't see trapezoids either, I see triangles. Alright, number 3, graph, definite integral from -1 to 3, absolute value of x over x. It's been a while since we played with this guy, but I would expect you to know this.
like that.
Jackie, what does it look like? Looks like this? Actually, I guess from your perspective, you guys should be looking at this. Okay, so I want the integral from -1 to 3 of the absolute value of x with respect, absolute value of x over x with respect to x. Here's the graph, y equals -1 to y equals +1, open circle, open circle. We're going from x equals -1 to x equals 3. When we look for the definite integral, it's always bounded by the function, the x-axis, from your starting point to your ending point. So what I'm looking for
1,
is that guy.
3.
Area for this region over here.
1.
Okay. area looks to me to be 1. Area for this guy over here
3.
is going to be 3, and I hope everybody's okay. This problem introduces something different that we haven't looked at yet. Beto?
Didn't you say if the area was under the x-axis would be negative? Oh, yeah,
Because this region is below the x-axis, we want to treat this special. If you have an area that's below the x-axis, the area has to be negative. So although the area is 1, because of the work that we're going to do in calculus, we're going to count that as negative area. Area below the x-axis is negative. Just like if you're going from right to left instead of left to right, negative area.
So it's gonna be 2?
So your final answer is going to be
2.
2. Negative 1 plus 3 is going to be 2. And everybody's still feeling good. Okay, last one. Definite integral from 0 to 3, square root of 9 minus x squared. And here's where I want to be kind because we're also running a little bit low on time. This is not a graph I would expect you all to know. Based on what I saw last year in pre-calculus when you guys were talking about conic sections, this is not something I'd expect you to notice on sight. No. What this guy here is a semicircle. I'll tell you what it is and then I'm going to shut up. This is a semicircle. The center of the semicircle is at the origin, and the radius of your semicircle is 3. That's all I'm going to say. Based on what your experience in pre-calc last year, I would not expect you to know this on sight, but I've given you all that I'm going to give. Once we finish this problem. The graph that we're looking at is a semicircle, centered at the origin, and the radius is 3.
What is it really bad?
Radius is 3. So a full circle would look like that. Semicircle, y equals, those are all positives. There's your semicircle. This is the graph of y equals the square root of 9 minus x squared. Specifically, what's the area that I want?
Right.
We want to go from 0 to 3.
Yeah.
Everybody okay to that part?
Yeah.
Okay, what are we going to do?
1/4 pi r squared.
Area for a circle is normally pi times r squared.
Yeah.
What we have is 1/4 of that. So we're going to have 1/4 times pi times my radius, which is 3. 3 squared, if all goes well, 9 pi over 4. And everybody's feeling really good. Like, best calculus day ever. Oh my God, I've understood everything from the time he started, maybe until the time that we end. Don't worry, I have 4 minutes to dash all your hopes. Okay, Abraham, if you could take control of the laptop, please. Everybody else, if you could take out your calculators. We're going to have some oohs and ahs. I will blow your mind. Okay, the 4 problems that we just did, we're going to redo. The first one, I think, was the integral from 1 to 4 of 3x plus 2 with respect to x.
Yeah.
Okay, on the calculator. Go to the home screen, please. Home screen. Everybody's on the home screen? Go to calculate. Menu. Anybody say anything helpful?
Calculus.
Calculus. Anybody say anything helpful?
Numerical integral.
Numerical integral. Wait for it. There it is. So let's redo the first one. The definite integral of 3x plus 2 with respect to x from 1 to 4. Trust your instincts here. Type in the 1, basically fill in the boxes. 1 to 4, 3x plus 2 with respect to x. And if all goes well,
28.5.
28.5. What did we get?
57 over 2.
57 divided by 2. Anybody know what 57 divided by 2 is?
28.5.
Half. Okay, what was the second one? Was it negative 2 to 2 absolute value of x with respect to x?
Yes.
Let's see if your calculator can handle that. So menu, calculus, numerical integral, negative 2 to 2. Absolute value, it's been a while, it's right next to that Bible. Right, it's the templates button that you're interested in. Absolute value of x with respect to x. And we hit enter. And we get 4. Everything's good.
Yeah.
Try the next one. Was it negative 1 to 3?
Yep.
I love the TI Inspire in that you get the opportunity to match exactly what is on the paper. Right? You don't need any special notation. Pop it in, and we're going to get 2, and that feels good. And let's see what your calculator knows about the last one. Integral from 0 to 3, 9 minus x squared with respect to x. Calculators have to come every day. Still have a calculator. 9 minus x squared with respect to x, 7.06858. What did we get?
9 over 4 times 5.
9 pi over 4. Now there is nobody in this room, myself included, that's going to look at that number and be like, oh, that's 9 pi over 4. Abraham, convince me that that's actually 9 pi over 4, please.
You go kill
Meaning like, there you go, 9 pi divided by parenthesis 4, 7.068. We got this under control?
Yeah.
Okay. Nothing that we've, you can close it. Nothing.